Ladies and gentlemen, boys and girls, welcome to SciShow Quiz Show, a gluten-free part of this balanced breakfast. Today on the show, we have Purple Tank co-owner Hank Green.
Hey, how's it going?
Hey. And we have Protein Pathway Grandmaster Ceri Riley.
Hi, Ceri is one of our writers for SciShow, and she's really excited to be here.
I'm so excited and definitely not terrified.
Good.
It'll be good.
You didn't write this one, though.
No, I didn't. I wrote the other one.
The Caitlin Salem one.
Yeah.
So, Hank.
Yes.
Today, you are competing on behalf of Patrick Merrithew.
Hi, Patrick. I paused for a while because I wasn't sure if Michael had pronounced your last name right, but now I feel like we should have just plastered right on.
To be honest, I'm not sure if I said it correctly either.
And not really questioned it, because we're just gonna have to guess.
Ceri, you are playing on behalf of Bader Algamdi.
Good. Let's go.
Get it over with.
Terrified at all.
Let's make this happen.
Okay, so both of you start off with 1,000 SciShow bucks. Each time you answer a question correctly, you will win some number of points. If you answer incorrectly, you will lose some number of points.
But not answering really isn't an option, because that just makes you look weak.
And whoever has the most points at the end of the game wins some fantastic prizes on behalf of their patron. So Stefan, what are we competing for today?
Thank you, Michael. Patrick and Bader will both receive signed cards from our final round with our contestants' final guesses and wagers on them. The runner-up will receive the I Lost SciShow Quiz Show pin. Very nice. And the winner will take home the I Won SciShow Quiz Show pin and some secret SciShow swag from dftba.com. Back to you.
Okay, you guys ready to hit the light?
Yes.
Sure.
It's starting to get pretty wintry here in the Northern Hemisphere, so our first round is about the cold.
Okay.
And our first question in this round is about the coldest continent. Not much can live in Antarctica, with all that ice and wind and freezing temperatures.
For a second, I thought the question was going to be, what is the coldest continent?
I
And I
was
was like,
thinking
boom, I got that one.
Africa!
Thought it'd be a trick question or something.
I
like
was so
Europe.
excited.
Yep.
Continue, sorry.
You're good.
Given that we've got the ice and the wind and the freezing temperatures, some animals are still able to manage with the help of some special adaptations.
Sure.
So the question is, what is Antarctica's most abundant land animal? Is it penguins, mosquitoes, nematode worms, or tardigrades?
I'm gonna go with nematodes. Do you want to know my reasoning?
Sure.
Because they're little and weird, and tardigrades, I feel like I would have heard about that.
Well, Hank, you are correct.
Hey!
So that's 100 points for Hank Green.
But I would not have been surprised if it were mosquitoes, because they go everywhere.
I was gonna guess
tenacious.
mosquitoes.
Life finds a way.
The answer is C, nematode worms. Nematodes have a few techniques for surviving in some of the coldest weather on Earth. Like some other animals that are adapted to cold, they have a compound called glycerol in their blood, which acts as an antifreeze. If it gets so cold that ice crystals start to form in their blood anyway, they also have special proteins that surround the crystals to protect their cells from damage. Nematodes can also protect themselves by what's essentially freeze drying. When the temperature drops too quickly, they let themselves dehydrate and enter a kind of inert state. Once it gets warmer again, they absorb moisture and go back to being their usual wormy selves. Penguins, meanwhile, aren't considered land animals at all because they spend so much time in the ocean. And there are no mosquitoes in Antarctica. Tardigrades do live there, though. We haven't directly counted the populations of nematodes or tardigrades, but by analyzing amounts of different species in soil samples, researchers have concluded that there are more nematodes in Antarctica than tardigrades, or any other land animal. The next question is about things that seem to work only at very low temperatures. Superconductors. Superconductors are materials that conduct electricity perfectly without the usual loss of energy that regular conductors have. But they only work at super cold temperatures. In 2010, researchers were testing a new kind of superconductor that was made by heating a compound called iron telluride in water. At one point, the team was at a party and came up with the idea of soaking the compound in different kinds of booze they had on hand, like beer, wine, and whiskey. Red wine turned out to be the best choice. It made 62.4% of the material become superconducting, 6 times more than plain water. Why? Was it because of the concentration of ethanol in the wine, the acid found in the wine, the compounds in the barrel used to age the wine, or the yeast in the wine?
I'm not gonna take that risk.
The acid in the wine?
Ceri Riley, you are correct.
Oh!
That's 100 points for Ceri
That's
Riley.
amazing. That was a guess.
Yep, I was between those two, the acid and the ethanol, but I had no idea which one it was. But I guess it makes sense, because all those other things have ethanol. But wine's definitely got more on the acidic department going. What else did they try? Did they like pee in there? Did they like do some like blood sacrifice to the...
I don't know, but future me is probably going to tell you about it right now. The answer is B, the acid found in the wine. Many of the alcoholic drinks the researchers tested increased the amount of superconducting material compared to water. Beer, for example, caused 37.8% of the material to become superconducting. But the red wine caused, by far, the highest increase. Researchers then tested different kinds of red wine and compared their effectiveness to their composition to try to figure out what was happening on the molecular level. Turns out that a type of red wine called Beaujolais increased the superconductivity more than the other kinds of red wine because it has more tartaric acid, a weak carbon-containing acid that's sometimes used in baking powder. In salt form, it's also known as cream of tartar. After some more research, the team concluded that weak carbon-containing acids increase superconductivity by changing the structure of the iron telluride. So as a biochemist and a biologist, you probably both know at least a little bit about the subject of our next round.
Okay.
Carbon.
Sure.
Okay.
Carbyne, with a Y, is a type of carbon that's structured as just one chain of carbon molecules with alternating single and triple bonds. It's stronger than any other known material, but it's also really hard to make. So far, the longest chains made in the lab have been about 6,400 carbons long. But Carbyne has been found naturally in some places, like meteorites. Where else might you find it? As an impurity inside a diamond, in the Earth's mantle, in the sun, or in interstellar dust?
I'm gonna say interstellar dust, but before I do,
You just did.
in the Mars trilogy, a space elevator collapses onto the planet, and in the process, like, it generates so much energy that it like whips around and causes a lot of destruction. But one of the things that it also does is create all kinds of crazy chemical compounds that they're then able to harvest that would never have been created in any other way because of the amount of energy that was involved in that. And one of them was weird carbon chains like that. So that's one place you might find it, in a collapsed space elevator. But additionally, since you said that it was in meteorites, I'm going to say interstellar dust.
Well, Hank, you are correct.
Hey!
Hey! The answer is D, in interstellar dust. German chemist Adolf von Baeyer first proposed the existence of Carbyne in 1885, but all he knew was that long carbon chains might exist. Ever since, researchers have been trying to figure out how to make these chains. But as you can probably imagine, it's tougher to engineer chains that are just one atom thick, especially because they aren't very stable. But in 1980, a group of astronomers from the Mullard Radio Astronomy Observatory in Cambridge, England, proposed that natural Carbyne could be found in interstellar dust. Earlier studies had looked at the electromagnetic radiation coming from interstellar dust to try to match up its spectroscopic signature with known compounds and see what the dust is made of. But parts of the spectra weren't a match for the compounds astronomers expected to find in interstellar dust. The Cambridge team realized that the data could match up with Carbyne, though. From the fact that Carbyne has been found in meteorites and other studies describing the conditions where Carbyne can form, the researchers concluded that these long carbon chains were in interstellar dust. So that's 200 points for Hank. Now, there's also a new form of carbon that was only invented last year. It's called Q-carbon.
Still doing it.
It's made by taking layers of non-crystalline or amorphous carbon, using a laser to heat it up, and then cooling it really fast.
Okay.
The team that invented Q-carbon also discovered there's something unique about it. What is that special property? Is it that Q-carbon is permanently magnetic, liquid at standard temperature and pressure, electrically conductive, or a superconductor?
Go ahead.
Okay, the superconductor one?
Ceri Riley, you are wrong.
Okay.
I'm gonna guess the one about it being a liquid.
Hank Green, you are also
Oh,
wrong.
I thought that
That
was
would
so
be really
cool.
weird, yeah.
It is that it is permanently magnetic.
That doesn't make any sense at all.
You should explain it to us, Michael.
The answer is A. Q-carbon is ferromagnetic, that is, permanently magnetic. Q-carbon is actually a lot like diamond, except that the carbons inside it are arranged much more haphazardly. And it's even harder than diamond. Q-carbon is also electrically conductive, but so are other forms of carbon like the graphite in your pencil. But Q-carbon is ferromagnetic at room temperature because of the disorganized way the carbons are bonded to each other. No other plane forms of carbon are permanent magnets. Our final round is actually about biology, specifically fish. Herring live in big, fast-swimming schools called shoals, and they have a unique way of keeping these shoals together, specifically at night. How do they do it? Is it by infrasonic communication, farting, vibrating their swim bladders, or swimming in circles?
Wait a second. That first thing wasn't even words.
Infrasonic communication.
What does that mean?
I think that's like below. I think that's like deep,
Yeah,
deep
like-
sounds.
Very
Like infrared,
long
yeah.
wavelengths.
Long wavelength sounds, which you might do by vibrating your swim bladder. So I'm just going to rule
Yeah.
both
How
of
I
those
do it.
out.
I don't know about you.
What were the other options?
Farting, obviously.
Okay.
Infrasonic
Block that one
communication, farting,
Okay.
vibrating their swim bladders, swimming in circles.
Yeah, and somebody has to do it.
The swim bladder one.
Incorrect.
Okay.
That's totally.
That,
Yep.
We're in the 300-point round, so I'm sorry to say that's
there's
minus 300
300 points.
that's a lot of points. It's
wow.
okay. It's fine.
All right, well, I feel an
expected it.
obligation to answer now. I'm going to go with farting.
Hank,
Is it farting?
you are correct.
Oh,
Bad. That's just rude.
I want to know more about this.
Well, let me tell you about it. The answer is B, farting. Herring release bubbles from their rear ends, especially at night, which makes a high-pitched noise that other herring can hear. The gas isn't because of something they ate. The fish specifically swallow air from the surface. When it's dark and there are lots of fish around, the herring fart to help each other keep track of the shoal. The fish that eat herring aren't as sensitive to high-pitched sound, so the herring can communicate with each other without telling their predators where they are. We have reached our double or nothing question, wherein our contestants can wager any number of the points they have. Hank is at 1,400. Ceri,
Good.
you have 600. So I can tell you that the next question is also about fish.
Okay.
I didn't do so well on the last one about fish. So.
Place your bets. We'll be right back after these commercial messages. Welcome back. Mangrove killifish are tiny fish that live in Florida, Central America, and South America. And what's weird about them is that they can survive on dry land for up to 2 months. And they have to, because they live in little pools of water that disappear during the dry season. The fish have lots of adaptations to help them survive on land, but which of the following don't they do? Lower their metabolic activity, breathe through their skin, bounce around using their tails, hunt for food on land.
What? They do one of those two things?
They do 3 of those things that I just said.
Yeah, but obviously they decrease their metabolic activity.
Yeah, that one is
Yeah,
that's a
and-
definite
and-
thing.
And I'm fascinated.
Okay.
You guys ready?
Yes.
All right. Show your answers.
Oh, we both said the same
Oh,
thing.
Wow, you're both equally wrong. The answer is lower their metabolic activity.
Are you
What?
serious?
Oh man.
Past me is really embarrassed. We were so sure.
Well, at least we're
That's okay.
together.
Yeah. And you met all your points.
I did, and so did you.
Yep.
Wow! So we
No
got a
one
tie with 0 points. The answer is A. Mangrove killifish don't lower their metabolic activity to help them survive on land. When their pools dry up, the fish just kind of keep going about their business. As long as they're kept moist, they can breathe and even excrete waste through their skin. They can move around on land either by wiggling their bodies or by using their tails to launch themselves into the air. Since they can move around on land, they can capture the insects they eat. So mangrove killifish don't really need to conserve energy when their pools dry up. They have no problem keeping their bodies going, even on land.
Well, I think that we could say that we both won, and so everybody's going to get something in the mail.
Everyone always gets stuff anyway.
Yeah, everyone always gets stuff anyway.
But everyone gets both pins this time. Woo!
This was an exciting quiz show.
Oh man, it was.
Thank you, boys and girls, for watching at home. If you'd like to help us make more stuff like this, you can go to patreon.com/scishow. And don't forget to go to youtube.com/scishow and subscribe.
I am internet.
Yes. Competing against Hank, we have the host of Cape Tectonics and rock and mineral enthusiast, Caitlin Salem.